Hi everyone. Now we are going to discuss about another one transistor circuit. It's a microcontroller based circuit. Here we are going to control the high current application. Here we are using the LED with 1.4 amps. The maximum current flowing through this LED is 1.4 amps and it's a high current application by using the microcontroller. Okay, and maximum output of the microcontroller will be the 10 milliamps. Okay, by using this 10 milliamps we are going to control the LED. How we can make this? I think we have aware about that the Darlington pairs. By using this Darlington pairs of transistor circuit we can control the high current application. What are the application by using this Darlington pair circuit? This circuit we can use it for the high current gain application and high current switching applications, and by using the low current we can control the high current application. Let us discuss one by one. As we discussed earlier, now we are going to control the LED with 1.4 amps, so that here maximum 1.4 amps of current flowing through this LED, so that we can consider collector saturation current IC sat is equal to 1.4 amps. And also we know that the maximum current flowing through the microcontroller output will be 10 milliamps. So that we can consider maximum base current IB is equal to 10 milliamps. So let us find the minimum base current which is required to drive the transistor circuit in the saturation region. Okay, which is equal to IC sat divided by beta, which is equal to 1.4 amps divided by, we have considered current gain of each transistor will be 100, that the total gain will be the 10,000, which is equal to 0.14 milliamps. So that this is the minimum base current need to drive the transistor in saturation region. So from this we can calculate the base current which is required to drive the high power LED. So that base current IB is equal to base voltage VB minus the voltage drop in between the base to emitter in the Darlington pair, which is equal to V base to emitter Darlington pair divided by base resistance, which we can call it as RB. So which is equal to 3.3 volt minus, and here we are considering the base to emitter voltage will be 1.3 volt divided by R, and which is equal to 2 volt divided by RB. By considering this equation, the base resistance is inversely proportional to the base current. When the base current is minimum, the resistance of the base will be the maximum. So that IB minimum equal to 2 volt divided by RB max. And also we know that the minimum base current will be 0.14 milliamps. So that the RB max is equal to 2 volt divided by 0.14 milliamps, which is equal to 14.258 kilo ohm. And as we know that the maximum current which can supply from the microcontroller will be 10 milliamps. So that here we can consider IB max will be 10 milliamps. That means when the base current is maximum, resistance of the base will be minimum. That means RB minimum is equal to 2 volt divided by 10 milliamps, which is equal to 200 ohm. So as per this we can conclude that when the base resistance is more than 200 ohm, the current drawn through the microcontroller will be less than 10 milliamps. So that if we want to control this LED, we have to consider the value of base resistance in between the 200 ohm to 14.2 kilo ohm. Hope we are able to understand what is the purpose of the Darlington pair circuit, and where we have to apply this Darlington pairs circuits and how to calculate the base resistance to control the high current application. I request you to kindly subscribe and like the video. Thank you. Thank you for the watching.